Alright everybody, good afternoon. Today we're going to look at techniques of differentiation. So we have several techniques of differentiation. One of them is product rule. We'll look at that. And then we'll also look at quotient rule. And then we'll end with chain rule, or whether we'll start with chain rule. So let's start with chain rule. Chain rule is simply if you have an expression that says in this form y equals to a function in x. Okay, it simplifies to dy over dx equals to dy over du times du over dx. We introduce u. So if you look at this, see that u dy du cancels out. So this strikes this out. So we are left with dy over dx. So I'll do an example and we'll see how that works. Alright, so we have this question. It says if y is equals to, we are given this question, if y is equals to 2x plus 2 all cubed, find dy dx. It's from the JAMB of 2013. So if y is equals to this, 2x plus 2 all raised to power 3, find dy dx. So let u be equals to what is ever inside the brackets here. So so you introduce a letter u. So you say let u be equals to what's inside the brackets here. Then that means that y will be equals to u cubed. If all of this is u, then y is equals to u cubed. Okay. Now the next now is to find du dx. If u is equals to this, then du dx must be 2. Same thing with y is equals to u cubed. Alright. So if u is equals to 2x plus 2, that means du dx will be 2, because you differentiate u with respect to x here. This is differentiating, this is 2. Now y is also equals to u cubed. So if you say dy du, if you differentiate this, gives you 3u squared. You have to agree. So by chain rule, this is the formula for chain rule. Dy dx equals to dy du times du dx. You can see that du cancels out. So what's on the left hand side is equals to the right hand side. So substitute in your values. Dy du, you know dy du is this. Dy du is 3u squared. Put it there. Du dx is 2. Put it there. So it multiplies out and gets 6u squared. But u is this. So substitute back and you have that. Alright, so let's look at this another question. The question says d dx, that's the differentiation of cos 3x squared minus 2x over with respect to x. That's the meaning of d dx. So the question says d dx is equal to, okay, this is a typical past question from JAMB. So how do you go about this? You simply say, okay, let this expression be equals to y. That's the first step. Then this next step is what is inside the brackets, because it looks a little bit complex. So just take only what's inside the bracket and let it be equals to another letter u. So you can easily differentiate u with respect to x. That's du dx becomes 6x minus 2. You have to agree. And the original expression y equals to cos, all of this complex expression becomes simply y equals to cos u. Okay, so we say y is equals to cos u because we've said let this expression inside the bracket be equals to u. That means y will be equals to cos u. All of this is u, letter u. So then if y equals to cos u, then you have to agree that dy du is equals to minus sine u. Now the differentiation of this is a trig function, cos, tan, sine. So it's already given in the formula. I will send it on a, you must have seen it. So it's already something you have to memorize. Differentiation of cos of anything is minus sine of that thing. So differentiation of cos u is minus sine u. So what's next step? You apply your chain rule. This is formula for chain rule. Now dy du is this. Okay. So and by chain rule, so the next step is you apply your chain rule. Now this is chain rule. Dy du is this. Then du dx we've gotten it as this. So just multiply them together. So dy du is minus sine u. That's it. And then du dx is this. So 6x minus 2 times minus sine u. So since this is an expression, what you do, you just pack it in front of or on the left hand of your trig expression sine u. So you have this. Now remember that you have to substitute it back. We said at this point, we said u should be equal to this. So put it back into your final answer. So this is the final answer. Alright. So that is chain rule, and that's how we go about it. Alright.